Thank you very much for the kind invitation and the introductory words. So my name is Gabor Sziebig, and I will be mainly focusing my speech today on this changing the rules of the construction. So what is our goal here is that we would like to expand the static BIM with dynamic information that is coming from the construction process. So the presentation that I will be doing here, it is connected to the second round of the digital twin call in the Horizon 2020 frame, and I'm the coordinator there. But let us start with a very short introduction on itself of what we would like to achieve with the project. So, of course, the focus is in digital twins, so improving building information modeling by real-time tracing of the construction processes. And for this, we have many different tools that we proposed in using in the project. These tools are kind of enriching the information in order to establish a twin, and also tools that are helping us to communicate this twin information out to the users. Let it be either construction workers or emergency personnel or site manager clients from the general contractor side. So it's a very kind of wide scope for the project itself. But today I will be focusing here on how to create a digital twin based on BIM information. So let us start with that. We should introduce very basic rules when you would like to create traceability on twins and digital twins. So first of all, we would like to start from a known position. So we want to have a kind of an information already started at the day one of the construction site, that what will happen and when. So this is the very first thing that, at least from our point of view, when we want to create a digital twin, we need information about the events that are supposed to be happening. If we have this, so then we can start building a twin. The second one, that all the revisions that are happening on the as design phase, we need to have a traceability on it. So any changes on the geometry, any changes on the timeline, we need to have it kind of traced on the BIM models itself. So we would like always to have a trace of the changes, not only that you provide a new revision, but we would like to change and see that what was changed. And in order to do this, we also introduce new properties that are always kind of following up all the parts that are deleted, that are added, that are altered. So we have always a very good traceability of what was happening. And the third, that we would like to also to include in the twin itself workers, machines, robots, drones that are in default not part of the original BIM IFC documentation. So all that things that are happening on the construction side, we would like have traceability with the proper unique identification. And if we keep these rules, these really simple rules that we would like to trace, so then at the end of the construction, we will be having a really good overview of what was happening on the construction site itself. And what the twin is, at least in our interpretation, should include, and this is related to also the keynote that was presented here on the level one, the information for the digital twin. And this is that we provide a timeline. So you will be like on the YouTube, you will be able to kind of go back and forth on the construction site and always know that what was happening there. So we create a timeline on the construction site that will be the part of the digital twin, includes all the information. Let it be either a task, let it be a kind of a construction step, let it be a resource. So robots, humans working there in this kind of timestamp way, so time-based database information, everything included there. And in addition to that, we also know and we also kind of follow up where are the workers on the construction site. So based on their location, zone-wise, not precisely, because to keep the privacy of the worker. So we are able to actually follow up that work need to be done and that was actually done or not. And we have also in possibility to introduce inspection rounds, so we can send the robot on kind of a mission to do the mapping and to look around. So these are all part of the digital twin itself. And how we see for us that how this will work. So first of all, we start with the design phase, where we know that how the building will look like. These inspection rounds result in a kind of, we can call it in as-built check, where we can find the deviation. when we define the deviation, this can be a result of a laser scan, for example. So we will clearly be able to identify that in the BIM model, there is a difference, there is a deviation. And if we know that there is a deviation, so then we are actually able to say that, okay, these are the two elements that have changed or wrongly placed, and this is not how it was built. Then we are able to, in the next step, say that, okay, actually one of the dimensions are not properly set. And then we can say that, okay, this dimension is wrong. So what would be in a normal world should happen is that we kind of communicate this information back to the owner of the IFC file. So for example, the architect will get an information about that, okay, the dimension of the wall, it was not that as it should be. And then we communicate back to the designer that, okay, you should do it through BCF communication, so that you should update your whole design and give us a new revision. However, this is very time consuming. So what is our focus is that actually we do a kind of, in a computer science word, a kind of forking here, that we kind of split the model into multiple stages, so that from this point, the twin has its own separated life with the introduction of a BIMprove property, that we are actually storing multiple copies of the identities of this BIM information, and until it is not proved, it is only just existing in the digital twin. So if we would kind of describe that how a twin works in our system, is that in the very beginning, our digital twin that is developed in the project is at the beginning, it is synchronized with the as-designed files. And then we, for example, receive an update from the architect that, okay, I have changed the dimensions of the window. This information is automatically kind of updated in the twin, and also stored in the as designed, officially contractually binding information for the whole construction, or for the building asset. In the meantime, we are doing the kind of the daily tracking of the construction site, and we figure out that there is a kind of a deviation. So that one is kind of highlighted here with the green as built update. So we find deviation and even more deviation, which are in default only approved in the twin side and not in the contractually binding as design model. So we kind of informate and store these kind of deviations in the twin itself, and notify the owner of the model part that, okay, this has been changed, so you need to have an action through a BCF information, and that you need to change your design officially. And until this is not done, this exists in the twin, but it is not binding totally as a contractual wise. But we submit these BCFs also to the designers, and then we get, as soon as we get the approval, we introduce these back to the design phase itself. So that is what we can say, that our twin is very much focused on the legislation part. So focusing on that, who is the owner, where it is coming from, and how we can introduce changes in a dynamic manner and get it also used in the contractual point of view. And these details we have been already published in a white paper that is focused on the digital twins and the data integration for the IECO sector, which can also be accessed from the following QR code. Behind the BIMprove project, we have 12 partners, leading scientific research organization, and also major industrial actors, and also standardization actors in this frame. So get us touch with us, and this would conclude my presentation. And thank you very much for the possibility.